In this video, we're taking a hands-on look at 3 powerful techniques that help you get the most out of your cloud data warehouse: dynamic warehouse scaling, zero-copy cloning, and concurrent transformation handling. Let's jump right in and see how these can boost performance while keeping costs in check. First, let's explore dynamic warehouse scaling. In Snowflake, I've set up a test warehouse, extra small, and disabled cached results for more accurate performance measurement. This means we're not going to benefit from any saved query results, giving us a fair test of our warehouse's capabilities. In Matillion, I've set up an environment to use the test warehouse I created in Snowflake. Next, I have an analytics pipeline based on a 28 million row flights dataset. This pipeline does some heavy lifting, including a join, some calculations, and sorting. Running this pipeline on a smaller warehouse would be cheaper per minute, but it will also result in longer runtime. To strike a balance between cost and speed, I'm using Matillion's alter warehouse component. I temporarily switch the warehouse from extra small to medium, run the resource-intensive job, then revert back to extra small. Notice the gray unconditional link in the job flow. This ensures we always go back to the smaller warehouse, even if something fails, preventing us from accidentally racking up extra charges. Now, even though medium has 4 times the compute power of extra small, you won't always see a direct 4 times speed up. Some operations hit diminishing returns. Still, scaling up strategically can be a game changer for time-sensitive tasks and may, in some cases, be less expensive. Let's break down the cost of our runs for a more complete picture. Although the overall cost of running the extra small warehouse is cheaper in Snowflake, once we factor in Matillion DPC cost, the medium warehouse comes out ahead overall. This underscores the importance of looking at your total platform cost to see the full financial picture and choose a good cost-performance balance. Next, let's talk about zero-copy cloning, a great way to set up safe testing environments without duplicating large datasets. In this parent orchestration pipeline, a simple SQL script component creates a clone of our flights table. Snowflake's metadata-only cloning references the existing data behind the scenes, so it doesn't add appreciable storage cost. Once the clone is created, I can experiment. In this example, I'm adjusting rounding methods to see how it impacts estimated fuel cost. This lets me test transformations on production-scale data, but with zero risk to the original tables. It's also easy to create views, materialize views, and dynamic tables using Matillion DPC. But in this case, zero-copy cloning stands out for its simplicity and minimal overhead. It's a strong approach to quick, iterative experimentation. Lastly, let's boost throughput by running transformations in parallel. Suppose we have 2 pipelines. One generates state-level metrics, and the other creates airport-level metrics. We could set up an orchestration pipeline that runs these jobs back to back, but then we're potentially doubling runtime and cost. Instead, setting up the orchestration job with separate branches for each transformation is better, since both will run concurrently. It's important to know that true concurrency happens at the orchestration level. Branching in a transformation job, like in this example, will typically translate into sequential SQL operations. That wraps up our look at dynamic warehouse scaling, zero-copy cloning, and concurrent transformation handling. With these tools, you can build a more efficient, cost-effective, and high-performing data architecture. As a next step, explore these methods in your own environment. If you're new to Snowflake or Matillion, both platforms offer easy trials, so you can jump in and start experimenting right away.